Hey everyone, welcome to our final video of the series. Now we are in this video just going to be tying everything we've learnt about particularly congruent triangles together, and we're going to be talking about using our understanding of congruent triangles to establish properties of quadrilaterals. So in other words, we are going to make some observations about things we already know about quadrilaterals and just use what we've learnt about identifying congruent triangles to pretty much confirm these, to prove these. Now, in this video, I also want to give you an introduction into some of the proof writing you're going to be doing in later years in school. And this is a pretty tricky skill to get. Some students don't really like it, but I'm hoping to give you just a little slow introduction into how we can go about this in this video, which will give you the foundation for when we talk about this in later videos. Now, let's just first redefine a quadrilateral. So a quadrilateral is essentially any four-sided shape. And we make some observations about quadrilaterals which can link congruent triangles. Because you can see in this rectangle I've drawn down here, I can make this rectangle, drawing this line through, I can see this is made up of two triangles. So there's an inherent relationship between triangles and quadrilaterals. And we're going to explore this a little bit more in this video. Now let's consider a parallelogram. I've drawn one on the right here. Let's just go through some of the things we already know about parallelograms. Something, just definitional things that tell us what makes a parallelogram. So, a parallelogram is a type of quadrilateral with both pairs of opposite sides parallel. So that means that opposite sides, this one and this one, for example, are parallel, as well as this one and this one. That is the definition of a parallelogram. Now there are a couple of other things we know about these. And that's that the opposite sides are equal, the opposite angles are equal. That's what I've put these two quote markings in for. It's just to say the same thing as up here. So we know opposite sides are equal, opposite angles are equal, and this third thing we may not have come across just yet, but I'm going to talk about it now, and our next example we're going to prove this third fact. So this is that the diagonals bisect each other. So these two diagonal lines, let me clear this image up a little bit. A diagonal, for example, is a line that stretches from the two diagonal corners of a shape. So this thing here would be a diagonal, as well as this one here. And we've encountered this new word, bisect. Diagonals bisect each other. Now, all this means is just to cut in half. So that means if I had just this diagonal here, if I were to draw my second one, it's going to cut this first line in half. Now, if it cuts it perfectly in half, that means that this side is going to be equal to this side. And the same happens vice versa. I can say that this diagonal is going to bisect this one here. So that means that both sides on each point of this cut are going to be equal. Now we want to prove this thing. And in doing that, we are going to be consulting what we know about congruent triangles, and we're also going to introduce this idea of proof writing. So I have a question here, and this is that we want to prove that the diagonals of a parallelogram bisect each other, and we want to give reasons. This is the most important part of this question. Let's look at, first of all, how we can even approach this question, because this is a little bit tricky. Now, I essentially want to prove that in doing this, I want to prove that this side DE is equal to this side BE. I also want to prove that the side AE is equal to the side CE. That is what I want to do here. So, I don't know enough about this parallelogram. I really don't know how to approach this question. What I do know how to do, though, is to prove that triangles are congruent. Because if I consider, for example, this triangle up here and this one down here, let's do that in this color. If I can prove that these are congruent, that they are exactly the same, that can tell us something about the respective sides. The sides from one that correspond to the sides of the other. So what I'm going to do now is I'm just going to redraw what's happening in my shape. I'm just going to make a diagram that's hopefully going to help me prove this a little bit. So say I take this and I draw it down here. And I'm going to label this in the same way so you guys can see where I'm going with this. And I will draw this line here to represent my diagonal here. And I want to make some observations. So this is side E. Now, if I want to prove anything in terms of congruence, I'm going to be considering one of the 4 tests we talked about before. So either side, 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 to tell that two triangles are identical. Either they're going to have all 3 sides equal, they're going to have 2 sides and included angle equal, or they're going to have 2 angles and a side equal, or they're going to have a right angle, a hypotenuse, and a side. Now, before even beginning my proof, can you think, are there any of these that from the information we're given that just can't be applied? Well, side, 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 I don't know enough about the sides here, about all 3 of these sides. I only know that this one and this one are equal, and I know that my lines are parallel here. So these 2 lines are parallel. I don't have enough to say for sure that all 3 sides are going to be equal. So I can rule this one out. Now I can also rule out this one down here, because this proof, if you remember, is just for right angled triangles. We need a right angle and a hypotenuse. Both of these 2 triangles, this one up here and this one down here, neither of those are right angled triangles. So I can rule out both of these options. So I know now that my proof that I'm going to use is either going to be side angle side or angle angle side. So let me just pop this down the bottom here. And now I'm going to start writing my proof. So let's take a minute to talk about actually writing these proofs, because I want to convey a bunch of information. Now you guys may want to think back to, say, something you may have done in English, right? Some of you by now should hopefully be looking at structuring coherent thoughts, structuring a paragraph, for example, to argue some kind of point. In congruence and proofwriting in particular, in maths, we are doing the exact same thing. So I like to tell my students that when talking about any idea, we want to give reasons for it. And this is in the same way that when we, for example, solve an equation, we show our working out. Now, how we're going to do this for congruence is we're going to split up our proof into 3 sections. We're going to have an introduction, we're going to have a body, so a section where we have our key ideas, and then we are going to have a conclusion. That's how we're going to structure this thing here. Now, let's shift this down a tad bit. In the introduction, we just want to introduce the two triangles we are working with. So I want to just introduce my two triangles. So I'm going to say in triangles ABE and triangle CDE. All I'm doing here is giving the reader an insight into what I'm going to be discussing. So I'm discussing the triangle ABE and the triangle CDE. Now in my body, I'm going to now start giving reasons for why I think these are congruent. So to do that, just underline this here. I know I'm going to be looking at either side angle side or angle angle side. In writing my proof, it's up to me to decide which bits of information I'm going to use and what do I notice from the diagram that's going to tell me whether it's side angle side or angle angle side. So I'm just going to look at my diagram and see any things that I can pick up. Now, because these are opposite sides of a parallelogram, I know, based on what we know about parallelograms, that this side and this side are equal. That is, you can think, given to us by the definition. And you can see, we can also say that because I have these markings here. For it to be a parallelogram, the opposite sides have to be equal. So I can say that side AB is equal to side CD, and this is given. This just means that this just tells us that we're told that already in the question by these markings. We are told that AB is equal to CD. Cool, that's a good start. Now, there's not a lot of other sides that are really telling me anything here. Because remember, when I introduced the question, our task is to prove that this side is equal to this one. We don't know that yet. We also want to prove that this one is equal to this one. So I'm not going to have more than one side in my proof. So I can cross out side angle side. This tells me I will likely be looking at an angle side proof because there's nothing more, there's no more information that's given to me about the remaining sides. So I have to consider the angles. Now, think back to last year's geometry topic and some of the angle relationships you've looked at in the past. What can I say about this angle and this angle down here? Just by looking at them, you can probably see that they look like they're probably going to be equal. Now, if I were to just draw something here, maybe it'll remind you of something that we learned before. If I just trace, whoops, wrong one. If I just trace out this here, I can see I'm making the letter Z. Now, there is something specific, something important about angle relationships with these little inner angles. And that is that these are always equal. We call these alternate angles. Let me draw in this angle here. So my two angles here are actually equal. Now, that means that angle CDE, based on the angle relationships that we learnt in the last year's content, the angle CDE, this one here, because the middle point, remember, of how I draw my angles, the middle one is the pointy bit that actually shows the angle. My angle CDE is equal to my angle ABE. So, and I've written this ABE with the B in the middle because that is the pointy bit where my angle is located. So I have made a statement that these two are equal. Now in my brackets, I want to give a justification, right? I want to support my argument. I can't just pick things off and just go, oh yeah, that's equal because it looks equal. I want to give an actual reason. Now we know the reason. And this is because these are alternate angles in parallel lines. This is an angle. Alternate angles are an angle relationship that arise when we have two parallel lines and a transversal going through them. We've done this in previous videos if you want to go back and have a look at that. So by that angle relationship, I can say that these two angles are going to be equal. Now, similarly, if I consider this angle at C and this angle at A, these are also alternate angles. I can see this Z shape being made. I have my two parallel lines, CD and AB, and I have these angles within them when I have my transversal going through. So I have that these are going to be equal. So I'm going to write here that my angle DCE is going to be equal to my angle BAE. And this is for the exact same reason. So I'm just going to put these little quotation marks because I'm quoting something I've already said before. So now I have in my congruence proof 3 key ideas. Remember, I need 3 bits of information to say that two triangles are identical, are congruent, are the same in every way. So in my conclusion, I'm just going to refer to the idea of congruence, the thing I'm trying to prove at the end of the day. So I'm saying, therefore, that's what these 3 dots mean, triangle ABE is congruent. Remember, that's like this triple equal sign thing here, is congruent to triangle CDE. And that is congruent because they have 2 common angles and a common side. So we are using angle, angle, side. Now, some of you may be looking at this and going, well, cool, you proved 2 triangles are congruent, great, but that's not what we're trying to find. We're trying to find that this is the same as this, or that this is the same as this. How do I do that? Based on the information given. Now, this is a reason why this is the very last topic we're doing in this series, because it's the hardest. It requires the most work. Now, if I just copy and pasted this thing, if I just copy this and paste it down here, we're going to make an observation. If this actually pastes. Here we go. Now, what if I were to take, because I know these are congruent, they're equal, they're identical, but there's not a lot I can do with these just yet. But what if I take, for example, this triangle up here and I do a rotation? What if I rotated this and translated a little bit so that it's in the same orientation as this one here? That would help me a lot in dealing with the corresponding sides that I want to prove are equal. So what I'm going to do is I'm going to perform a series of transformations on my triangle DCE. So I'm going to rotate it and I'm going to translate it. So I'm going to, when I rotate, my side C, my point C is going to be down here. My point E is going to be up here. And my point B is going to be down here. And I'm going to make another triangle. So I've effectively taken this top one and I have rotated it. Hopefully you can see how I've done that. And I have translated it down. Now let's redraw this. Up to E and going down here. And I'm going to make these same markings just so you can see how this corresponds. I have this one here. I have this one here. I have this equal side still, and I have my parallel lines. Okay, now, because these are congruent, that means all of the sides are going to be equal. So I already know this one's equal to this one, so I can just pick off, well, in that case, this side AE is the same as this side CE. And also, this side EB is the same as, that's meant to be a D, is the same as ED. So these sides now are equal. Now let me mark this on my original image I had. So I'm going to mark that this side EA is the same as EC. So the side EA, this one here, is the same as EC. I'm going to write that in. EA, this marking here, is equal to EC. Okay, that tells me that this line, DB, must have bisected this line AC because I have two equal sides on each end. That's one bit of information. Let me actually do these as doubles. So another thing I'm going to do is I'm going to mark on my diagram that EB is equal to ED. So EB, 1, 2, 3, EB is equal to ED. So that tells me that my line here must have also bisected this line. Because remember, bisecting means to cut in half. So both of these respective lines have cut the other in half. So after I have my congruence statement, I can then say, therefore, BE is equal to DE and AE is equal to CE. And then that means that the diagonals bisect each other. So therefore, the diagonals bisect each other. I have come to the end of my proof. So this was a two-parter question and it was a little bit harder. It involved a lot of mental rearranging of the images, breaking this up into two triangles and then just matching those sides to the ones in the question. But you can see we've effectively proved what we needed to prove. And we proved a property of a parallelogram, that the diagonals bisect each other. We proved this through applying what we know about congruent triangles. Now we're going to do a lot of this in a later series. So if this is a little overwhelming for now, don't stress too much. We're going to go through it a lot in depth later. But thank you so much for joining me in this series. I'll see you in the next one.